Okay, so you should have just completed watching the video on bungee jumping. Just to give you some context, today we're going to be talking about dealing with two variables at one time. Okay, and we're going to be thinking about how is the stretch of a bungee cord related to the weight of a bungee jumper. So if we were in in-person class, or maybe this is something you could try on your own, what you could do, all right, is you can take a weight and attach it to a rubber band and see what happens as you put a heavier weight on it. And we can complete a table of values for this. So in your notebook, okay, as I go through this, I want you to copy down this table of values. So I want you to copy down the words weight attached in grams and the length of stretched cord. If you need to pause this video to stay caught up, feel free to do so. So when we have no weight on there, we might have the cord is stretched to about 30 centimeters, okay? When we have a little bit more weight on there, we might find the cord is stretched to 20. When we have 20 grams of weight, we might find that the cord is stretched to 40 centimeters. Let's change the color. Let's say we put on 60 grams, then we might have 60 centimeters of stretched cord. 80, and you're probably seeing a pattern here. No, you're not, because I forgot to type something in. It's 20, 40, I missed one. 0, 20, 40, okay. We're going to try a 60 gram weight, an 80 gram weight, and then a 100. And let's say in an experiment when we tried this, we went from 30 centimeters stretch to 40 centimeters of stretch to 50, 60, 70, and 80. Okay? We're going to be talking about the pattern we see in this data, and we're also going to be talking about the rule. But before we do that, let's plot these points. So you should set up an axis, and I want you guys to copy down, all right, copy down your two axes right here, and copy down the title of each axis. We have the weight attached, which is our X, okay? And then we have the length of the stretch cord, which is our Y, our X and our Y. Feel free to pause to get caught up in the notes. So we're going to plot each point. When we have 0 weight attached, so when the weight attached is 0, the length of the stretch cord is going to be at 30, okay? So if this is counting by 40s, halfway between 40 and 0 would be 20. So 30 would be this halfway point right here. When the weight attached is at 20, now notice, there's no 20 here, but we know that halfway between 0 and 40 is 20. So when we're at 20, this is at 40, and we're going to plot a point right there. When the weight attached is 40, the length of the cord is 50. So let's put a little dot at 50. So we've done 1, 2, 3 dots. Check your notes, make sure you have 3 dots. When the weight attached is 60, the length of the cord is also 60. When the weight attached is 80, the length of the cord is 70. And when the weight attached is 100, the length of the cord is 80. We'll notice that all these lines will connect in a straight line. Maybe you remember what type of function that's called. Next up, I want to talk about the pattern of change. And when we talk about the pattern of change, we talk about two different variables changing. So our two variables here are the length of the stretched cord does what? Increases by blank as the weight attached increases by blank. Okay? So the length of the stretched cord increases by, let's see, we go 30, 40, 50, 60 inches, 10 centimeters as the weight attached. Look how the weight's changing. It's going from 0 to 20 to 40 to 60 to 80 to 100. Is increasing by 20 grams. Okay? All right? So we've done two things so far. We've plotted from a table. okay? Table of values. And we've described the shape, the pattern, okay, of the table of values. We've done two things. The next thing I want to do is I want to check to see if a rule matches the equation. So if I said a rule you could use for this scenario would be that the length L is equal to 30 plus 0.5 times the weight. Would that work? Yes or no? So the way we're going to check this is that we're going to be using some substitution. So let's say we take a look, and let's take a look at this first column right here. Okay? When the weight is equal to 0, do we get 30? So let's test out everything we have here. The 30 stays plus 0.5 times 0. So remember our order of operations. 0.5 times 0 is 0. Is 30 equal to 30 plus 0? It is. So the rule does check out for our first data value. Let's check one more. Does our rule check out for our second, this data value, let's say 80 and 70? So our length is 70. And is that equal to 30 plus 0.5 times 80? Keep in mind, all we're doing is replacing this W with the weight in the table. 0.5 is the same as 1/2, or you could use your phone calculator to compute this. 0.5 times 80 would be 40. And is 30 plus 40 equal to 70? The answer is yes, it is. So this is a good match. It checks out. Okay? And in fact, you could check all of the different data values and this rule would work. So this is a good rule for this scenario. All right, let's take a look at our next problem. So we're still in the bungee business. All right, so designing the bungee jump apparatus is only part of the task of adding the attraction to the amusement park. It is also important to set a price per jump that will make the operation profitable. So think to yourself, would you pay to go bungee jumping? And how much? The 5-star marketing staff did a survey of park visitors to find out the number of customers that could be expected each day for the bungee jump at various possible price per jump values. And here's the data that we came up with. Okay? So they said if it didn't cost anything, 50 people would show up and do it. If it cost $5, 45 people would do it. If it cost $10, 40 people would do it. Okay? And so on. The pattern continues. Maybe you're looking at this and noticing, wow, there's a pattern. But before we do the pattern, let's plot the points. So I'm going to take this and I'm going to put this on a new tape page. This would be a good chance for you to take a minute and copy this into your notes. Otherwise, your plot's going to not have any context. Copy into your notes. So take a minute and pause this to copy it into your notes. Okay, next we're going to be plotting these points. So we're going to set up two axes, 1, 2, and I'm going to label each one. My bottom axis, my independent axis, my x-axis, I'm going to call the price per jump, and I'm going to say that's in dollars. And my vertical axis, I'm going to call likely number of customers, okay, like that. And here we go, and it's like this, boom. There we go. Now we have to plot this. Now notice that our x goes 0, 5, 10, 15, 20. Let's make it easy. Let's just count this by 5s. 5, 10, 15, 20, 25, 30. And our up and down axis, and we notice it goes from 50 to 20. I'm going to count this by 10s. 10, 20, 30, 40, 50. And the halfway point is going to be like my 45 or my 35, my 25, my 15, or my 5. Okay? So what we're going to do now is we're going to plot each of these points. So 0 and 50. When the price per jump is 0, we're going to have a point up here at 50. When the price per jump is 5, we have a point at 45. And remember, that's my halfway point. You know what? I can even make this even look like really nice. I know I can do it. And no end. Let's just make it look really nice. You guys are worth it. You're worth it. Oh, I skipped one. Okay. And we'll just go through. So we did this point, 10, 40. So at 10, we're at 40. Yeah, so see how I'm noticing? I knew I needed to make those lines because I was like, I'm going to not do an awesome job here. Okay. 10, 15, 35. 20 goes with 30. 25 goes with 25. Okay. And 30 goes with 25, and 30 goes with 20. Okay. We're just going to plot these points. We would connect them. You notice they make a straight line. There's a special name for that function. Maybe you remember it. If you don't, it doesn't matter. We're going to go through it. We'll review it in a minute, or we'll be reviewing it next week. So here we go. So the next thing I want to do is to describe the pattern. So we describe the pattern by completing this sentence. So let's say the likely number of customers is going to do what? Will increase by how many? Okay, for each now. And is it increasing or decreasing? Ooh, it's going down, baby. Okay, decrease for each increase in how many dollars? Okay, that's the question we want to answer. And we want to look at our table. So we have that in our table. This is decreasing by 5, right? So it would decrease by 5 people for each increase in, now this is going up by 5. Okay? That's the pattern we see in the table. The next thing I want to do is I want to check a rule. So once you have that copied into your notes, all right, they're all copied into your notes, we're going to check the rule. So let's say our rule, we might check for this is the number of people is equal to 50 minus 50 minus P. And let's just check it. So if we were to take the number of customers and we say that's 50 minus P, or the price. Okay, so in this problem, this P represents the price and the number of customers is right here. That's our N. Okay, so let's check a value. Let's check this one. Does this work? Is 30 equal to 50 minus 20? Is 30 equal to 50, that's from here, minus 20? And the answer is yes, it is. So that checks out. Let's check one more. Right here. Is 40 equal to 50 take away, what do we have? 10 is our price. It is. Check. This one checks out. If we went through the whole table, they would all check out. So for both of these problems, we've done a few steps. Okay, for both of the problems, we have we've gone through, we've plotted the points from the table, we've described the pattern by filling in the blank, and we've checked a rule. That's the expectation for what we're learning about today.